Imagine waking up one morning, stepping out of your house, and suddenly the ground beneath your feet begins to move. Buildings tremble, windows shatter, and within seconds the world around you turns into chaos. Roads crack open, bridges collapse, and the earth that once felt solid suddenly becomes unpredictable. This is the terrifying power of an earthquake, a natural force capable of reshaping cities, changing landscapes, and altering lives in just a few moments. But here's something even more fascinating: earthquakes do not happen randomly. Deep beneath our feet, the earth is constantly moving, shifting, and building up enormous pressure. When that pressure is finally released, the result is a violent shaking that can be felt for hundreds or even thousands of kilometers. Why does the earth shake like this? Why do some countries experience earthquakes frequently while others rarely do? And could a powerful earthquake strike anywhere on Earth, even in places people believe are completely safe? Today on Geraldinho Academy, we are diving deep beneath the surface of our planet to uncover the science behind earthquakes, their causes, their devastating effects, and the regions of the world that are most vulnerable to this powerful natural phenomenon. By the end of this lesson, you will understand why the ground beneath us is not as stable as it seems, and why understanding earthquakes could one day save lives. Let us begin by understanding what an earthquake really is. An earthquake, simply put, is the sudden shaking of the ground caused by a release of energy deep within the Earth's crust. This energy travels through the Earth in the form of waves known as seismic waves, which move through rocks and soil and shake everything in their path. The exact location beneath the Earth where this energy is released is called the focus, sometimes referred to as the hypocenter. Directly above this point on the Earth's surface lies the epicenter, which is usually the area where the shaking is strongest and where the most damage often occurs. When an earthquake begins at the focus, the released energy spreads outward in all directions, much like ripples that spread across the surface of water when a stone is thrown into a pond. But instead of water waves, these are powerful vibrations moving through the Earth's crust. To truly understand why earthquakes happen, we need to take a journey beneath the ground and explore the structure of our planet. The Earth is made up of three major layers: the crust, the mantle, and the core. The crust is the thin outer layer where all living things exist. Compared to the rest of the Earth, it is extremely thin, in some places only about 5 kilometers thick beneath the oceans, and around 30 to 70 kilometers thick beneath continents. Beneath the crust lies the mantle, a massive layer of hot, semi-solid rock that extends nearly 2,900 kilometers deep. The mantle is not completely liquid, but it is flexible enough to slowly flow over time, almost like very thick honey. At the center of the Earth is the core, an extremely hot and dense region composed mainly of iron and nickel. Temperatures in the core can reach more than 5,000 degrees Celsius, hotter than the surface of the sun. However, the crust is not one solid, unbroken shell. Instead, it is divided into several enormous pieces known as tectonic plates. These tectonic plates float on top of the slowly moving mantle beneath them. Although they move very slowly, usually only a few centimeters each year, their movement over millions of years shapes the continents, forms mountains, and opens oceans. But when these plates interact with each other, the results can be dramatic. Sometimes plates move toward each other, sometimes they move away from each other, and sometimes they slide past each other. And it is at these boundaries between tectonic plates where most earthquakes occur. One common cause of earthquakes occurs at transform boundaries, where two tectonic plates slide past each other horizontally. Because the edges of these plates are rough and uneven, they often become stuck due to friction. As the plates continue trying to move, stress slowly builds up along the boundary. This stress may accumulate for years, decades, or even centuries. Then suddenly, the rocks break or slip. The stored energy is released in an instant, sending seismic waves through the earth and causing the ground to shake. A famous example of this type of boundary is the San Andreas Fault in California. This massive fault line marks the boundary between the Pacific Plate and the North American Plate. Although small tremors occur regularly along this fault, scientists know that large earthquakes can also happen when enough pressure builds up over time. Another major cause of earthquakes occurs at convergent boundaries, where two tectonic plates collide. In many cases, one plate is forced beneath the other in a process known as subduction. As the descending plate sinks deeper into the mantle, intense pressure and friction develop along the boundary. When that stress is suddenly released, the resulting earthquake can be extremely powerful. If such an earthquake occurs beneath the ocean floor, it can push enormous volumes of water upward and generate a tsunami, a massive sea wave capable of traveling across entire oceans at speeds of up to 800 kilometers per hour. One of the most devastating examples occurred in 2004, when a massive undersea earthquake in the Indian Ocean triggered a tsunami that affected more than a dozen countries and tragically claimed hundreds of thousands of lives. A third type of plate interaction occurs at divergent boundaries, where tectonic plates move away from each other. As the plates separate, magma rises from deep within the earth and cools to form new crust. This process is constantly creating new sections of ocean floor along underwater mountain chains known as mid-ocean ridges. Although earthquakes at divergent boundaries are usually smaller, they still remind us that the Earth's surface is constantly being reshaped. Interestingly, not all earthquakes are caused purely by natural tectonic movements. In some cases, human activities can also trigger earthquakes. Activities such as deep mining, drilling for oil and gas, injecting fluids underground, or building extremely large reservoirs behind dams can sometimes alter pressure within the Earth's crust. These disturbances may trigger small earthquakes, a phenomenon known as induced seismicity. While most of these human-induced earthquakes are relatively minor, they highlight how sensitive geological systems can be. Now let us explore the effects of earthquakes. When a powerful earthquake strikes, the ground shaking can destroy buildings, bridges, highways, and pipelines within seconds. Structures that were not designed to withstand seismic forces may collapse under the intense vibrations. In densely populated cities, this can lead to catastrophic loss of life and widespread destruction. Entire neighborhoods may be reduced to rubble. Transportation systems can grind to a halt. Electricity, water, and communication networks may fail. The economic consequences can also be enormous. Governments may spend billions of dollars rebuilding infrastructure, providing emergency aid, and restoring services. But the impact of earthquakes goes far beyond physical destruction. Families may lose their homes. Schools and hospitals may be damaged or destroyed. Communities often face emotional trauma as survivors cope with loss and the challenge of rebuilding their lives. Earthquakes can also trigger secondary disasters. Landslides may occur in mountainous regions as unstable slopes collapse. Fires may break out if gas lines rupture. Flooding may occur if dams or levees fail. Undersea earthquakes can generate devastating tsunamis, while strong shaking in volcanic regions may even trigger eruptions. A dramatic example occurred in 2011 in Japan. A massive earthquake beneath the Pacific Ocean generated a powerful tsunami that struck the Japanese coast and caused severe damage to the Fukushima nuclear power plant. This disaster demonstrated how a single earthquake can trigger a chain of complex and dangerous events. This brings us to an important question. Why do some regions experience earthquakes more often than others? The answer lies in the distribution of tectonic plate boundaries. One of the most active seismic zones on Earth is the Pacific Ring of Fire, a horseshoe-shaped region that surrounds the Pacific Ocean. This region contains about 75% of the world's active volcanoes and experiences roughly 90% of the world's earthquakes. Countries such as Japan, Indonesia, Chile, Mexico, and the Philippines lie along this zone and frequently experience seismic activity. Japan alone records thousands of earthquakes each year, although many are too small to be felt by humans. Other earthquake-prone regions include the Himalayan region, where the Indian plate is pushing into the Eurasian plate, slowly lifting the world's tallest mountain range. The Middle East, Turkey, Iran, and parts of Central Asia also experience earthquakes due to complex plate interactions. Although Africa generally experiences fewer large earthquakes compared to some other continents, seismic activity still occurs in regions such as the East African Rift, where the African continent is gradually splitting apart. Even countries that appear geologically stable can experience occasional tremors caused by ancient fault lines or localized stresses within the crust. For example, although Nigeria rarely experiences strong earthquakes, there have been occasional reports of mild tremors in certain regions. Because earthquakes cannot yet be predicted with perfect accuracy, preparation and awareness are extremely important. Scientists study earthquakes using instruments called seismographs, which detect and record ground vibrations. By analyzing seismic waves, researchers can determine where earthquakes occur, how deep they originate, and how powerful they are. Some countries have developed early warning systems that detect the first seismic waves and send alerts seconds before stronger shaking arrives. Although the warning time may be short, even a few seconds can allow trains to stop, factories to shut down machinery, and people to move to safer locations. Engineers have also developed earthquake-resistant buildings designed to absorb and dissipate seismic energy. These buildings often use flexible materials, shock absorbers, and deep foundations that allow them to sway rather than collapse during strong shaking. In earthquake-prone countries like Japan, strict building codes have saved countless lives. At the individual level, people can also take steps to stay safe. Heavy furniture should be secured to walls. Emergency supplies such as water, food, flashlights, and first aid kits should be kept in accessible places. Families should also create emergency plans so everyone knows what to do during an earthquake. One widely recommended safety method is drop, cover, and hold on. When shaking begins, people should drop to the ground, take cover under sturdy furniture, and hold on until the shaking stops. Simple actions like this can dramatically reduce injuries during earthquakes. Earthquakes also provide scientists with fascinating insights into the structure of our planet. The most powerful earthquake ever recorded occurred in Chile in 1960, reaching a magnitude of 9.5. This enormous release of energy was so powerful that it slightly altered the Earth's rotation and changed the length of the day by a tiny fraction of a second. Scientists have also observed unusual animal behavior before certain earthquakes. Dogs may bark excessively, birds may fly erratically, and fish may behave strangely. Although researchers are still studying this phenomenon, some believe animals may detect subtle vibrations or changes in the environment before humans can. Despite centuries of scientific progress, earthquakes remain one of nature's most powerful reminders that our planet is alive and constantly evolving. They challenge our engineering abilities, test our preparedness, and remind us that the ground beneath our feet is part of a dynamic geological system. Understanding earthquakes does not eliminate their power, but knowledge gives humanity the ability to prepare, adapt, and protect lives. And that is exactly why learning about earthquakes is so important. Now we would love to hear from you. If scientists created a completely safe earthquake simulation laboratory where you could experience what a real earthquake feels like, would you be curious enough to try it? Do you think technology will one day advance enough for scientists to predict earthquakes days or even weeks before they occur? Should governments continue building large cities in earthquake-prone regions, or should development in those areas be limited? And here is a thought-provoking one. If you had the power to design the perfect earthquake-safe city, what features would you include to protect people and buildings? Share your thoughts in the comments. Your ideas might inspire someone else to think differently about our planet. If you found this lesson interesting and informative, don't forget to like the video, subscribe to Geraldinho Academy, and turn on notifications so you never miss our deep explorations of science, geography, and the fascinating world we live in. Here on Geraldinho Academy, we transform curiosity into knowledge, and knowledge into understanding. And remember, the earth beneath us may move, but an educated mind always stands firm.